Okay, good day. I apologize for my absence today, but I just wanted to do a quick lesson here and give you some examples. Today we're going to talk about finding inverses of linear equations. This week, fairly easy week. We're only going to do one lesson. We're going to talk about linear inverses today and nonlinear inverses tomorrow. We'll do a practice quiz on Wednesday, and then on Thursday we'll have a quiz over just one lesson, and then on Friday we will do Super Fabu Fun Day as we get ready to go into spring break. So first, what is an inverse function? An inverse function, which is denoted with that f with this superscript -1. It's not to the -1 power. It is a superscript -1 of x. And the way that you read this is f inverse of x. And so essentially what an inverse does is if you have a function, you plug in an x, you get a y out. And then if you plug that y into the inverse, you'll get this original x back out. So essentially what it does is, or the way that you should think about inverses, is just the x's and the y's are switched. And that's all that inverses do. So as a for instance, if I have this relationship of ordered pairs, and this is just a set of points in a coordinate plane 1, 5, 2, 7, 3, 9, and 4, 11, then the inverse is the set of ordered pairs all obtained by exchanging the coordinates. So 1, 5 becomes 5, 1. We're just switching the x's and the y's. 2, 7 becomes 7, 2. 3, 9 becomes 9, 3, and 4, 11 becomes 11, 4. Again, just switching x's and y's. So if you're given an actual function equation, there is going to be some steps that we're going to follow. And again, when you see this notation right here, it is read f inverse of x. So the question may be posed as find the inverse of x. And the steps that you're going to do is check to see if the function is one-to-one. If not, limit the domain. Now, we're not going to have to worry about this part today because all of our functions will be one-to-one. We'll talk about that tomorrow. All we're going to do is we're going to switch the x and y values in the function. We're going to solve for y, and then we will label it as an inverse. Now, very quickly, usually our f of x is what we call y, and so if I'm following those steps, switch the x and y values in the function and solve for y, then I am going to rewrite this as x is equal to 2y minus 3. And we're going to solve this for y. So solve for y, and we'll add 3 to both sides. So I'll go plus 3, I'll go plus 3. These are unlike terms, so I've got x plus 3, and then I have 2y over here. Here we will divide by 2. And so when I divide by 2 here and I divide by 2 here, I will get y is equal to, because these cancel, I'll get y is equal to x plus 3 all over 2, and then we'll write our final answer, and we'll change this y into f inverse of x is equal to x plus 3 all over 2. All right, next example. Here I have a few more steps, but I'm going to essentially do the same thing. Again, remember, this is your y right here. So the first step is to switch your x and y. So I will go x here equals negative 3y plus 2 all over, plus 1 all over 2. And to solve for y, we're going to multiply by 2. And so when I multiply the whole thing by 2, these two cancel, and then 2 times x is 2x equals negative 3y plus 1. Here we will subtract 1. I'll go minus 1, minus 1. These are unlike terms, so they will cancel. And I'll have 2x minus 1 is equal to negative 3y. Here we will divide by negative 3. So when I divide by negative 3 on that side, it cancels. Divide by negative 3 there. Nothing cancels because I have 1, 2, 3 terms, and there is nothing common between all of those terms. So my final answer All right, I get y by itself will be equal to this 2x minus 1 all over negative 3. And we will finish that off by using the proper notation. F inverse of x is equal to 2x minus 1 all over negative 3. We'll put a box around that and we will call it finished. Finally, my last example for the day. Here I have two fractions, but you will notice that both of these have a denominator of 5. So I'm going to rewrite this as 4x minus 1 all over 5. Because the denominators are the same, I can add these two fractions together and get that. We'll switch our x and y like we did in the last two examples. So I'll have x is equal to 4y minus 1 all over 5. Here we will multiply by 5. And so when I put parentheses around there and I go times 5, the 5 cancels out there, and then 5 times x gives me 5x. Then I have 4y minus 1. Here I will add 1, so I'll go plus 1, I'll go plus 1. These are unlike terms, those cancel, so I have 5x plus 1 is equal to 4y. Then I will divide by 4. So divide by 4, those cancel. I get y is equal to this expression right here. I'll have 5x plus 1 all over 4. And then I will rewrite that as f inverse of x is equal to 5x plus 1 all over 4. All right, folks, those are my 3 examples for today. Yeah, I know I went quick, but you can always go back and pause and check your work with that. I also will include a full answer guide for you to look at on the Google Stream today. Thank you very much. Have a good day. Goodbye.